Okay, so same game we were playing yesterday. Same thing. Nothing's changed. We're solving derivatives, pretty much. That's what we're doing. We're solving derivatives. Differential equations are just derivatives. To do that, you have to do antiderivatives, right? So these are the 4 steps. Everything y related goes to the left. Everything x related goes to the right. That's the first thing. Second thing, integrate both sides. We haven't seen any where we need to do u substitution, but we will today. There will be some where we need to do u substitution because that's a part of, u substitution is a part of antiderivatives. Okay? Once you integrate both sides, if you're given a point, plug it in, solve for y. Number 3, we won't always be given a point. Like on the practice, the first 4 problems, 1, 2, 4, and 6, you're not given a point on the practice, so you don't have to do step 3. On 7, 8, 9, and 10, you are given. Okay? All right. So you are given a point. So it just depends. If you are given a point, step 3. If not, don't worry about it. Okay? All right, so let's go to example number 6. Okay? Example number 6. So the particular solution means you find C. You find out what C is. So we got to find out what C is using the point. Okay, so we have our differential. We have our derivative. All right, so we write this down. This is where we start. We start with our derivative equation. X squared times 2y minus 1 squared. And then we have our point here. First step, everything with a y goes left, everything with an x goes right over the equal sign. All right. So dx is the easiest because we've done that before. Multiply both sides by dx. So we have dy equals x squared 2y minus 1 squared dx. We still got a y here, though. I still have a y. This guy here has a y. So how do I move that guy over to the other side? How do I move the blue guy over? Again, I have 4 options. I can add it, I can subtract it, I can multiply it, or I can divide it. So the blue guy, is that being multiplied with what's going on over there, or is it being added to x squared? Is it being divided by x squared, multiplied by x squared, subtracted by x squared? Which of those is it being done? Multiplied, right? Multiplied. So once you know that, just do the opposite. Divide. Divide by everything I don't want, which is this part here. That just makes a giant 1 because anything divided by itself makes a 1. So I get 1 over 2y minus 1 squared dy equals x squared dx. Step 1 is done. Everything with a y moves to the left. Everything with an x moves to the right. Step 2, antiderivatives. Okay? This is where I was talking about here. To do the right side, you just add a power, divide by that power. So that side, not going to be that bad. That side's going to be 1/3 x cubed plus c. Add a power, divide by the power. The other side, though, we're going to have to use u substitution. The only way to do it is by doing u substitution. And the first thing is we need to get rid of the fraction because we don't have a quotient rule. For u sub, we do not have a quotient rule. So this guy is going to be u. Okay. Let's see. Move all this a little bit over here so I got some room. Okay. So u is going to be 2y minus 1. Du is 2 dy, because it's not dx, because the left side's dy. Then I'm going to divide by 2. 1/2 du equals dy. Now I'm ready to plug back in. Okay, so I haven't done antiderivative yet of this side. So it's going to be u to the negative 2 times 1/2 du. And the other side's already done. Okay, I can move the 1/2 to the front, just like I did last chapter. Now I can do the power rule. So I get 1/2 u to the negative 1 okay, move u back in. 1/2 2y minus 1 to the negative 1 equals 1/3 x to the third plus c. So because it has a negative power, it's got to move down. So far, it's nothing we haven't done. You've done u substitution before. You just had a test on it. Okay. Antiderivative done. Next step, plug in points. Plug in your point. Okay. So my points, when I plug in 0, I should get 2 as an answer. So 0 for x, 2 for y. 0 for x, 2 for y. So everywhere I see a y, I need a 2. Everywhere I see an x, I need a 0. Okay, evaluate. Let's see. 2 times 2 is 4, minus 1 is 3, and then 3, so in here I get 3. 3 times 2 is 6. Over here, 0 cubed is 0, times 1/3 is still 0. Let's just see. Okay. So now I'm going to go back to this guy here, and I'm going to plug in c. So I have 1 over 2y minus 1 equals 1/3 x cubed plus 1/6. Last step, I got to solve for y. Okay. So what I got to do here, so y is down here. Okay. So what I'm going to do first, it's being multiplied by a fraction. So that fraction is 1/2. 1/2, it's 1/2 times that. So what I'm going to do is I'm going to multiply by the reciprocal of 1/2. 2. That gets rid of the fraction, 1/2. So now I have 2/3 x cubed plus 2/6, which is 1/3. My question is, how do I solve for y? What do I do mathematically? Because again, I have 4 options: add, subtract, multiply, divide. What am I going to do to get y by itself? Again, this has nothing to do with calculus. This is not calculus. This is just getting up, solving for x, solving for y, right? So it's not like, it's not anything you guys don't know how to do. You guys have done this. So what steps can I do to get y by itself? I can't add one because it's under a fraction, right? So what can I do though? What are my options? In other words, how do I get y by itself? And I've said this since August, and I'll say it at the end of February. The hardest part about this class isn't the calculus. It's stuff like this. This isn't calculus. This is just algebra. Getting the letter by itself, solving for x, solving for y. You guys have done that since 6th grade, right? That's the hardest part about this, about this class. Questions like that. If I asked you guys to find the antiderivative, you guys know what to do. If I asked you to find the derivative, you guys can do that. If I ask you to find the limit, you guys got that. But it's things like this that are tough, right? So let's throw out some ideas. What are some ideas to get y? Might work, might not work. We don't know. So I can move it to the top, right? So to do that, I have to give it a power. So let's see. 2y minus 1 to the negative 1, right? Let's see if this works. Okay, so no more fraction, which I like, but it has a negative 1 power still. I want to get rid of that negative 1 power. If I didn't have that negative 1 power, I'd be great, right? I would be fine. How do I get rid of that negative 1 power? There's a couple different things you can do. How do I get rid of that negative 1 power? So see, how do I put this without giving? So there's many ways to do it. There's not just one way. But again, you guys kind of have our problem here. We want to move this guy to the top, right? And we tried that here, but it still has that negative 1. That negative 1 power is still a problem, right? We can't get rid of that. So the only way to get rid of that is by getting rid of this. How do I get rid of this? Times it by the reciprocal, right? Times it by the reciprocal of this, which is 2y minus 1 over 1. Okay? So let's try that. So let's multiply by the reciprocal, 2y minus 1 over 1. 2y minus 1 over 1. This side goes away, right? Just becomes positive 1. this side becomes this. There you go, yeah. There you go, yep. So now I'm happy that 2y minus 1 is no longer underneath a fraction. I like that. There you go. So now I'm happy with this stuff over here because it's not underneath a fraction. So since this is being multiplied times this, divide by what I don't want. What I don't want is this stuff over here. There you go. Anything divided by itself just makes 1. Okay? So now that stuff you could leave on the bottom or you can give it a -1 exponent. It's up to you. So now that we have that, now I can add 1 to both sides. Plus 1. Divide by 2. But instead of dividing by 2, because I already have a division problem over here, right? I'm going to multiply by the reciprocal. I think it'd be easier just to multiply by 1/2. So you get y equals 1 over, and then I distribute this guy over here and over here. So I would get 1 over 1, let's see, 2/6, which is 1/3, x cubed. Then 1/2 times 1/3 is 1/6, plus 1/2. Okay. All right. So again, the hardest part about this won't be the calculus part. It won't. The calculus part is only antiderivatives. Step 2. Step 2 was the only part that was was calculus related. Step 1, get it left. Step 1 was get the y's to the left, x's to the right. That's not calculus. Step 2, calculus. Step 3, plug in numbers. Solve for c. That's not calculus. Step 3, or the last step, step 4, solve for y. That's not calculus. So step 2, and I think you guys are going to find step 2 is the easiest. These are the hardest. How do I get y by itself? How do I get the x's to the right and the y's to the left? How do I solve for c? That's not calculus, right? So again, that's why we have, another reason why we have the summer assignment, because those things are very important. Okay, most people who struggle with this class struggle with those things and not necessarily calculus. Okay. Okay, so last problem, number 7. So dy, so we're going to do the same thing. dy over dx equals 2 times sine of x times y minus 3. Okay. First step. Y is to the left, x is to the right. Y is to the left, x is to the right. Okay. How do I get y minus 3? So right now, again, this guy has a y. How do I get that on the other side of the blue line? Divide. Because it's all multiplication, divide. So you get 1 over y minus 3 dy equals 2 times sine of x dx. Step 1 done. Step 2, antiderivatives. There will always be one side that's easier to do than the other. Usually the right side. Usually the right side's easier to do than the other. By easier, I mean you don't have to use U substitution. That's what I mean. Okay? So to do the right side, I'm going to have to do U substitution. I have to move this to the top. I can move the 2 in front because the 2 is just a multiplier. Okay? You don't have to, but it's probably easier to move it to the front of that. Okay? So for this side, we're going to have to use U substitution. This is going to be U. So over here, I'm going to set it up as U. So I'm going to take a little detour over here. So U equals y minus 3. Du equals 1. dy, because it's a y's, we're using y's, not x's on this side. The right side, we're using x's. Left side, we're using y's. Divide by 1. You get du equals dy. Du. Okay? So we use the power rule and it doesn't work. What happens when the power rule doesn't work? It's because, what's the antiderivative? Natural log. Natural log. Natural log of u, that's that side. So put u back in, it's natural log of y minus 3. Now we can do the other side. The other side's not as hard. It's just the antiderivative of sine. The antiderivative of sine, I can never remember if it's negative cosine or regular cosine. What is it? Sine? Sine, negative cosine. So it's going to be negative 2 cosine of x plus c. Okay. Calculus done. Step 3, plug in our points. 0, negative 1. Plug in 0 for x, negative 1 for y. Here's where it gets a little, not weird, but here's natural logs can't be negative. I can't take a log of a negative number. If you don't believe me, you can ask your calculator. Any log of a negative number will not work. Watch. Natural log, where is it? Natural log, negative 1, doesn't work. Logs can only be positive. Why can logs only be positive? Because it's a power. It's asking you this question. Natural logs are e to what power makes that number in there? There's no power that can make a number negative. I can make the number bigger. I can make the number smaller. I just can't make it negative or 0. So that's why, like, I can't pick any number. Pick any number. It's like 10. Can't do that, right? I can't do that. I can make it small. I can make it very, very small, but it still be positive. So a lot of times you'll see this. A lot of times you'll see when they do this, they'll put these guys, bars around it. I don't usually put those unless I need them. I need them now. Because on the inside, I'm going to get -4, right? Well, the absolute values, just use the absolute value. So instead of -4, we'll just make it +4. Which is, I don't know, some number. It's 1 point something. Okay? Since we can't use a calculator, we'll leave it like that. And then -2. What is cosine of 0? 1. Okay? So we have natural log of 4 equals -2 plus c. Add 2 to both sides. There's c. Okay? So we're going to go plug that in over here, right here. So the natural log of y minus 3 equals -2 times cosine of x plus the natural log of 4 plus 2. Okay. This looks very, very complicated, and it's really not. The reason is, what's our last step? We're almost done. We got one more step to go. What's step 4 always say? Solve for y, right? We only have one y. I only got one y. It's right there, right? But the problem is it's trapped inside of a log. How do I get rid of the log? We haven't talked about this in a while. We have, but not in a while. How do I get rid of a log? I can't divide by a log. So log, doesn't matter what log it is. You have a base, right? Natural log has a base of e. That's why it's natural log. Then you have a number, and then that equals an answer, right? To get rid of the log, you use the little loop, right? The little loop. Loop starts with the base, goes over here, goes over here. So the base becomes a base, but exponent base. And then y power equals x. For natural log, it works the same way. The only difference is, what's the base of a natural log? E. So e to this power equals x. So let's go back to our answer here. So this guy is going to have an e power here, right? So what we're going to do is we're going to do our little loop trick. Start with that guy. That's the power. It's got a heck of a power. That guy is going to be the answer. So it's going to be e to that power. It's got a big power. I don't even know. It's just a long power. Personally, I don't care because I just need to get y by itself. I'm not going to have to do anything with that power. I just write it down. It's going to equal y minus 3. How do I get y by itself? Plus 3. Three plus this long old power equals y. So you see natural logs and you see e's in this class a lot. Why? Because they're a lot more intimidating to look at than they are to work with. What's the derivative of e? E itself, right? So it's not hard. And then how do I change a log to an exponent? You just use a little loop trick, right? So it's not hard. That's why they put a lot of e's and ln's in this class, because it looks very intimidating, but it's really not. Okay? Okay, so we're going to pause there with the notes. On Monday, we'll pick it back up. So what I want you to do for the rest of today and tomorrow is work on that practice. Okay? I'm not sure yet, but I might not be here tomorrow. Okay? I might not be in class. I have to see. I have